explain high availability techniques such as stateful switchover. In order to have or use this feature, you will need a device that has two route processors or RP. That will happen if you have two supervisors, or in case you have a 90,000 Catalyst series stack-wise solution. So if you need two supervisor cards, you will need to have any of these chassis-based catalysts, and then you can use any of these supervisor cards. Remember that the primary supervisor card is known as active, and the secondary is known as standby. So what this feature does is synchronizing active processes and configuration information from the active to the standby. So this will allow the standby to immediately take over if the active fails. So you will be copying information from the active to the standby. So if this supervisor of active card fails, this standby supervisor will take over. Or in the case of an stack-wide solution, if the active device fails, the standby device will take over. When SSO copies information from the active to the standby, that is known as checkpointing. And if you're using in-service software upgrades, remember that this feature will help you automatically upgrade your operating systems when the network is running. This feature in these cases will upgrade the standby first and then the active supervisor. In order to know exactly what services are supported by SSO, you can issue this command, show redundancy clients, so you will see the processes and protocols and features that are protected by SSO. Notice that these are mainly layer 2 features. There are two types of switchover. You can have an automatic switchover if the active device crashes, reboot, or is declared dead or non-responsive. And there is a manual switchover that you can start if you issue the command redundancy for switchover from the command line interface. This is the evolution of this feature. The first feature that came in was route processor redundancy. That will take over more than 2 minutes to accomplish the switchover. This is known as cold redundancy because it didn't do any checkpointing at all. Then a route processor redundancy plus came in, which is known as a warm redundancy feature. It will take around 30 seconds to complete. This will make some checkpointing. SSO does a full checkpointing, and it is known as hot redundancy. And it will complete in less than 1 second to 3 seconds to complete, depending on the platform. So in order to configure, you will issue the command redundancy and then enter the mode. For all devices, you could enter here RPR or RPR plus, but who will need that, right? In order to validate your configuration, you can use show redundancy, look for the operating redundancy mode here, set to SSO, or show redundancy states, look for an active and standby device. Notice the word hot here. That means that you're using SSO. You can see here, for instance, warm if you're using RPR plus, or cold if you're using RPR.